Our topic today is to review scientific notation. If you notice the values in the first row of this table, they are written in standard notation. Just below each of those values, the same or the equivalent value is there in scientific notation. So notice how there's only one digit in front of the decimal for each of these values. One non-zero integer is what we aim for. So in order to make that happen, you need to move the decimal to that position. So for 91,000, for example, you would start with the decimal at the end of the value and move it so that it's right in between the 9 and the 1. So you'll notice we moved it 4 places to the left. When you move the decimal 4 places to the left, you're supposed to have a positive 4 exponent, or add 4 if there's a previously existing exponent. In the next example, we have a rather small number, 0.00451. You'll notice that the decimal needs to be moved once again between the 4 and the 5. The first non-zero integer is where we stop. So 1, 2, 3, 4. That's 4 places to the right. And because we're moving right, we're going to have a negative exponent. So that's where the negative 4 comes from. And then finally, we have 73.5 times 10 to the power of negative 6. So that is a pre-existing exponent that we have. So when we move the decimal to the correct position for scientific notation, right after the 7, that's one place value to the left. So that means we're going to add 1 because we moved to the left. We're going to add 1 to the negative 6, and that will give us the negative 5. Okay, so to recap, just remember, when you move the decimal to the left, you're going to add to the exponent or make the exponent more positive. And when you move the decimal to the right, you're going to subtract from the exponent or make it more negative. So in your notes, you have a few more examples that you can look at in normal notation or standard notation. And it shows you how to move the decimal point and what to do with the exponent as you move the decimal point each time. And then down below, you have some values that already have pre-existing exponents. So it tells you what to do here if you need to move the decimal point to put the value in scientific notation, and what to do with the exponent, whether you're supposed to add or subtract. So you can read through those and look at more examples on your own time. Okay, we're going to look at this table and do 6 problems together, and then the remainder you can do on your own. So we'll start with the first value, 56,700. So it says here to convert to scientific notation. I'm going to add that we'll also record our final value in significant figures. That'll give us a chance to review that concept as well. So notice 56,700. There is no decimal point present in this value. So that means these 2 zeros, remember, are trailing zeros, and they are not significant. So they will not be included in the final value that's recorded. They aren't significant because, again, there's no decimal point. So in order to write this value in scientific notation, the decimal point needs to be right here between the 5 and the 6. So to get it there, you need to move 1, 2, 3, 4 places, and we're moving to the left. So that means we're going to add 4 to that exponent. So 5.67 times 10 to the power of 4 is our answer. Let's look at the one underneath it, 555 million. So once again, no decimal point existing in this value here. So that means that these zeros that are present, the trailing zeros, are not going to be significant and will not be included in our final answer. In order to write this in scientific notation, the decimal point needs to be right between these 2 5s. Okay, so remember, only one non-zero integer is allowed to be present before the decimal. So 5.55 times 10 to the power of, count up those zeros. So we move the decimal 1, 2, 3, 4, 5, 6, 7, 8 places. So 10 to the power of 8. For our next value, we have a very small number. So we're going to move the decimal this time to the right. And how many places? Well, that depends on where our first non-zero integer is. So we're going to stop moving the decimal point once we get to this position between the 6 and the 2. So that's 1, 2, 3, 4, 5, 6, 7. So 7 places, and we're moving right. So hopefully you remember that when we move right, the exponent is going to be negative. So 10 to the negative 7. Okay, let's take a look at some of the examples in the other column with already pre-existing exponents. So the first value, 185 times 10 to the power of 5, in order to write that in scientific notation, we need to put the decimal point right here in between the 1 and the 8. Okay, and so since there are no placeholder zeros, leading zeros, or trailing zeros, everything there is significant. Okay, all those digits are significant, so we're going to include all of them in our answer. So 1.85 times 10 to the power of, we move the decimal 1, 2 places, right? And we moved it to the left. So that means we're going to add 2 to the exponent. So this is going to be 10 to the power of 7. Okay, our next example, 0.00725. So we're going to move the decimal over. So that's between the 7 and the 2. We stop after the first non-zero integer. So 7.25 times 10 to the power of, let's see, 1, 2, 3. We moved it to the right. And remember, when we move the decimal to the right, we're going to subtract 3. So minus 6 minus 3, that's actually negative 9. Okay, and then finally, we're at 300 times 10 to the power of 6. So these are trailing zeros. There is no decimal present, so these zeros are not significant and will not be included in the final answer. So in order to write this value in scientific notation, the decimal would need to be here between that 3 and the 0. So that would be 3 times 10 to the power of, well, we moved the decimal point 2 places to the left, so we're going to add 2 to this number. So 6 plus 2 is 8. So that's our final answer. Now let's take a look at some multiplication and division problems that involve scientific notation and recording our answer in scientific notation. These are some examples that you can review, and let's take a look at one from each section, one for multiplication and one from division. So for multiplication, if you choose to do these with a 4-function calculator, then what you would do to multiply is you would just multiply the numbers before you reach the base 10, and then add the exponents. So for example, with the first one, 2.13, you would multiply that number by 8.50. And notice you've got 3 significant digits in each of those values. So when you record your answer, you could simply write 18.1. And then it says to add the exponents, right? So our exponents are 5 and negative 3. And so when we add 5 and negative 3, we get 2, positive 2. Okay, now the final rule is to move the decimal as needed so that only one non-zero integer appears before the decimal point. And then we're going to adjust the exponent accordingly. So if you take a look at where the decimal point is right now, it's after the 8. It needs to be before the 8. So if I move the decimal over 1 place to the left, that means we're going to have to add 1 to our exponent. So instead of 2, we now have 2 plus 1, which is 3. So that gives us 3 as our exponent. Okay, and then you can take a look at the next example if you would like to review that later. For division, it's a similar idea. We're going to divide the numbers that are given to us before the base 10 and then subtract the exponents. So let's take a look at our numbers. 8.5 divided by 9.1. That's 2 significant digits in each of those values. So when you divide on a 4-function calculator, you'll get 0.93. The next step is to subtract the exponents. So regarding the exponents, we have negative 2 and negative 3. So negative 2 minus negative 3 gives us positive 1. Okay, negative 2 plus 3, right? So the last step then is to move the decimal as needed so that only one non-zero integer appears. And that would require moving the decimal point between the 9 and the 3. So right here, one place to the right. And remember, when we move right, we subtract. So 1 minus 1 will give us 0 for our exponent. And this is our final answer. All right, let's do a couple examples together. Before we do, though, you're free to use a calculator that's scientific or graphing. And these are the steps that you would follow to use a scientific or graphing calculator. So most scientific calculators have a key that's labeled EXP or EE. And that's usually used to enter the numbers in scientific notation. So for example, if you were going to enter this value, 3.6 times 10 to the 5 to 10 to the power 5 on your calculator, then this would be the key sequence. 3.6, 3.6, then EE5. That's how you would enter this value on your calculator. Okay, let's try a couple of examples. We'll do 2 multiplication problems and 2 division problems together. So go ahead and take a moment and get your calculator out. Okay, before we get started, notice the directions. Solve and express the answer in significant digits and in scientific notation. So we'll take a moment and select the 4 problems that we'll be doing together and determine how many significant digits are required in our final answer. So let's start with the first problem. In 8.100, we have 4 significant digits. Those are trailing zeros, remember? So both of those zeros are going to be significant because there's a decimal present. Next, we have 7.50. So once again, a trailing zero in the presence of a decimal. So that's 3 significant digits. And the rule for multiplication is to use the lower number of digits in your final answer. So our final answer is going to have 3 significant digits in it. The next problem we'll do is this one here. 3.9876 has 5 significant digits, and 4.265 has 4. So once again, the lower number is the number that our final answer will be recorded in. So we'll have 4 significant digits in our final answer. And then lastly, we'll do 2 of the division problems at the bottom. So we have 9,600. So that's 2 digits there that are significant. Remember, the trailing zeros, because there's no decimal, are not significant. So 2 digits there. And then 3.0 also has 2 digits. So our final answer will be recorded using 2 significant digits. And then finally, we have 0.0560. So that's 3 significant digits. These 3 are the ones that are significant. The 2 zeros in front, remember, they're placeholder zeros or leading zeros, which are never significant in a value. And then 3.31, all 3 of those are significant. So our final answer will be recorded using 3 significant digits. All right, let's begin the calculations, starting with the first problem. So when you're entering this value into your calculator, you would type 8.1, and you can type in the zeros if you like. And then what you want to do is look for your EE key. So there's mine up at the top. And then plug in your exponent, which in this case is 3. Okay, notice the 3 right there as the exponent. So plug in the 3, and then times 7.50 exponent 5 equals. So that's a really big number. So luckily, we're going to record it in scientific notation. So when we record our answer, remember, we need 3 significant digits only. So 6.08. You want to preserve the place value of the highest value numbers. So 6.808 are in the highest place values. And remember to round 7 up to 8 because of the 5. So our exponent then will be, you need to count your zeros. So 3, 4, 5, 6, 7, 8, 9. So we're going to move the decimal over 9 places to the left. That's why it's a positive 9. So that the decimal ends up after the 6, the non-zero integer. Okay, so now we're looking at this one right here, 3.9876. So that's what we're going to enter into our calculator. So 3.9876 exponent 12. And this time we have a negative number. So you got to look for that plus minus symbol. Okay. Times 4.265 exponent 6 equals. Okay, so that's a really small number. So once again, we're going to have to move the decimal point, and we're going to move it 1, 2, 3, 4, 5 places. So it's after the 1. So it's 5 places to the right. So hopefully you're understanding that it's going to be a negative exponent because we're moving the decimal to the right. So we need 4 significant digits in our final answer. And our final answer then will be recorded as 1.701. Remember to round that last 0 up to 1 because of the 7, times 10 to the power of negative 5. Okay, let's look at our last 2 problems. So we're doing some division. And we're going to be working on 9,600 divided by 3.0 times 10 to the power of 8. So let's type that in. 9,600 divided by 3.0 exponent 8 equals. Okay, remember to record only 2 digits in your final answer. So 3.2 times 10 to the power of, let's see, we're moving the decimal point to the right, so it's going to be a negative exponent, and we're moving it 1, 2, 3, 4, 5 places. So it lands between the 3 and the 2. Okay, one more. The last problem. Point 0.0560 exponent 3 divided by 3.31 exponent 5, but don't forget the negative, equals. Okay, so that is a pretty big number. Luckily, we only have to write 3 digits because there's only 3 significant digits in our final answer. So we're remember to preserve the place value of the highest value numbers. So that would be 1.69 times 10 to the power of, let's see the decimal between the 2 and the 9? This is 1,691,842. So there's a decimal right after the 2. We're going to move that decimal 6 places, and we're moving it to the left. So that means we're going to have a positive exponent. So that's our final answer. And that's our lesson on scientific notation.